15. The radius of circle A is 5. Now, we can use the radius that's already drawn, or we can draw in a new radius if we want to be advantageous. The radius beats the tangent line, you get a right angle. We could do that. The radius of circle C is 15. So we already have a relationship there. We've got the 5 and we've got the 15. It's kind of like a 1/3 relationship going on already between those two triangles. ED is a common tangent. That's just a fancy way of saying, hey, ED is a tangent for both circles. So it does serve as a tangent line to both circles. We want to find X, Y, and Z. Who has an idea of where we could start? Yes? Good question. Could you do a proportion to get the sides? Now, you're allowed to set up a proportion if two triangles are similar. If they're not similar, proportions won't work. If they are similar, then the proportion is the way to go. Do you remember how to prove two triangles guilty of being similar? That's okay. You don't have to remember it for right now. But angle is a great way. And I know I have 90-90. No questions there, right? When the radius meets tangent line, you get a right angle. And angle is congruent to itself. So these guys are similar. They are similar about angle. And when I did this for some students, the light bulb kind of went off and it helped them. When I took this and I big time rotated it and I showed them that this looks like what they've already seen in another unit. Let's see, that would go here. And this is X. Now let's set up a proportion. Let's set it up the right way because there's definitely a wrong way to set this up. Alright, I'm going to say 5 is to 15. 5 is to 15 as, don't say 12 is to X. I'll talk about why this is wrong. Yes. Okay, let's talk about that. 5 is to 15. 5 is an entire side. It's a whole. 15 is an entire side. It's a whole. 5 is to 15 as 12. 12 is an entire side of this purple triangle. It's the whole side. What about X? It is not a whole side. X is just a partial side. We don't say whole is to whole as whole is to part. That doesn't even make sense. So we need to get the whole side, which is X plus 12. From here, we're just doing our favorite cross multiplication. Let's do it. 15 times 12 divided by 5. $36. So 36 equals what we haven't found yet, that last part. And then we just subtract 12. So this is good old algebra at its finest. X is 24. Now from here, now that you've unlocked that, you can do a lot of Pythagorean theorem now. You see what I'm saying? So you can do 5, 12, oh, that's a triple, 5, 12, 13. And then you can find this whole side and do 15 with that whole side, do Pythagorean theorem again, and then you can do some subtracting. Are we good here? Give it. Oh. Okay. All right, what else? R and U are tangent circles. What do you think that means if a circle is tangent to a circle? They intersect one time. They intersect one time, they meet at one point. So their meeting here is pretty much telling us there's no overlap. So we actually know the length of RU. What is it? 20. It's 20. Because R to this point is 12. It's a radius. A radius is a radius throughout the whole circle. And this one is 8. So we already know RU using the fact of segment addition. Honestly, that's what we're using. Segment addition and radius. Okay. Next one. We need to find TU. So let's call it X. Call it X. I'm going to say 8 is to 12 as 8 came from the small triangle. Give me a side up from the small triangle. X is to, not 12 plus X, 20 plus X, or X plus 20. The whole side, TR. That's okay. Let's cross multiply. 12 times X, 12X. Your algebra teachers will be so proud of us in geometry, continuing algebra throughout the year. 8 times X is 8X. 8 times 20 is 160.
Yeah.
Subtract 8, 4x equals 160. We can divide that in our head. 160 divided by 4.
40.
I'm not drawn to the scale. My favorite. I love when the pictures are so grossly not drawn to scale. Okay, are we good on that one now? To find QS, unless someone knows a better way, the only way I could think of just by staring at it right now is to do Pythagorean theorem once, to do Pythagorean theorem twice, and then to subtract them. Okay? So I think that's how you're going to find QS. Number 14, ABCD is a circumscribed quadrilateral with AB is 16, BC is 20, and AD is 12. It's not very often that you get to be creative in math. You don't get to be creative very often, but this is a problem when you get to be creative. Everyone in the room could start this problem a different way, and we will all end up with the same answer. The reason I'm saying that is because we do not know any of these segments. We don't know this one or this one, but we sure do know that they're the same length. We don't know this one or this one, but we sure do know they're the same length, and so on. So you need to start with one of these numbers, and you need to split it up. I don't even mean you need to split it in half. You don't have to do that. You just need to start with a number, and you need to split it up. Pick a number. Heard 16 first. How do you want to split 16 up? Don't do half and half.
4 and 12.
We don't want it to feel like it's a coincidence. 4 and 12. If you split it up a different way, 6 and 10, you're going to end up with the same answer as us. This is going to create a domino effect. This is 4. This is 4. This is 12. This is 12. Okay, 12 minus 4. 8, 8. Ice cream cone theorem. We're using it 4 times. 20 minus 12. 8, 8. And no matter what, your DC is going to be 16. Like I said, it might be 6 and 10. It might be 12 and 4. It might be 8 and 8. We might not get the same answers here, but when we add them up, no matter what, it'll be 16. Yeah, okay. And we are looking for if the measure of RPQ, there's a lot of angles going on here, isn't there? RPQ, this angle is 35. Then we want to know the measure of APC. So we want the whole thing, right? Am I reading that right? Here's the theorem. If I have 2 tangents, if I have an ice cream cone, and then a segment comes through that angle, and it goes through the blank of the circle, center, if it goes through the center of the circle, then it bisects the angle. This is actually another problem that we need to divide that 35 up ourselves. Because what it doesn't bisect, B, does not necessarily bisect the 35. Well, B is not a line, but I can't call it PB, peanut butter. Peanut butter does not necessarily bisect RPQ. But what we can do is, let's put 35, let's split it up. What do you want to do? You want to do 5 and 30? Are you crazy? Okay, so we'll make this be 30, and this is 5. What is true is that this one got bisected right here. 30, 30. See that? 30, 30, 5, 5. So 35 didn't necessarily get bisected, but the one going through the center, got bisected. So you could have split it up any way you wanted to, but when you add them all up, you will get the answer 70. Yeah. Yay! Okay, we'll get 70. Okay. I think that's enough from the